Smart quiz number 2. And you know what else I forgot? I should have gone good old Ann. Number 1, Logan, I like this question. I like this question. I like this question. Why did I say that? Which test? You're not writing a test on work and energy this year, so which test? Really? You picked up on that? Good for you. Work is going to be, in this case, when we're lifting, it's mgh. When we raise or when we lift something, it's force times distance. Which force? It'll be the same size as mg. So it's going to be 688 times 9.8 times 2.4. And when I crunch the numbers, I get 16,000. I'm going to write this as 16,200 joules, but I'll store this on my calculator. Okay. 2.4 meters is about 3/4 of the way to the ceiling. 45 seconds to take that, not very fast, but 688 kilograms, that's a big mass. This is just a really slow motor that's slowly doing the job. How much power? Well, power is work over time. And so it's going to be this number, 16,200, but I'm going to use my answer button, divided by 45 seconds. You get 359.6. I'm going to go 360. Power is measured in watt. Watts. 1 mark. How much work will I do if I carry an 8.8 kilogram bag 9.3 meters forward? Why none? Why is the answer 0? Why can't you go force times distance here? You might recall I probably had some basketball players piggyback each other. It's usually a basketball player that I pick. And the issue is the distance is in that direction, but when you're carrying, the force is in that direction. Those of you that were in my class this morning during Flex, one of my international students was doing a complicated electric question, and you heard us discussing it, and suddenly I had my aha moment. Of course there's no energy because the direction of motion is perpendicular to the force, so no work is being done, so the physics is okay. Okay? Now, I fibbed a little bit. Jackson, could you stand? No, you know what? I won't have you do a piggyback. We're going to use our imagination. Antonio, in real life, when you're giving something a piggyback or when you're carrying something, you have a whole bunch of muscles that are contracting and expanding in the vertical direction, which is why you are getting tired even standing still when you're carrying that person. Technically, you are using energy and technically you are doing work, but work isn't being done on the person. You're losing the energy in the form of heat. An electric motor develops 65 kilowatts of power as it lifts a loaded elevator. How much force? Well, power is work over time. This is 2 marks, which suggests I'm going to have to do some thinking. You know what? Power is force times distance over time. Kemley, what did this want me to find? How much what? Get the F by itself. Times by T, divide by D. I did a quick check. They gave me power. They gave me distance. They gave me time. This will work. Here's another equation for force. Don't memorize it. Apparently, force equals power times time divided by distance. Apparently, that'll also be newtons somehow. It's going to be 65,000 times 35 divided by 17.5. This might work out evenly, does it? To 130,000? 130,000? Or am I wrong? No, I'm missing a 0. Maybe I'm right. Yeah, 130,000? Well, somebody should have said something. Newtons. Okay. 2 marks. How would I give you 2 marks? I would probably give you 1 mark if I would give you actually a half mark if I saw that. I would give you 1 whole mark if you got to that line. That would get you 1.5 and then a half mark for the answer. Number 4, a rifle can shoot a bullet at the speed of, find the kinetic energy, 1 mark, straight plug and chug. Kinetic energy is going to be a half mv squared. It's going to be 0.5. Nice try, Mr. Dueck, 0.0 0.0042. I got to divide by 1,000. So 0.0042. And then times 965. This is a very fast bullet, about 3 times the speed of sound, squared. 0.5 times 0.0042 times 965. Don't forget the squared. And I get 1,950. I'll call it 1,960 joules of energy. Is that okay? Yes? People nodding? Good. What work is done on the bullet if it starts from rest? Well, it's going to be the change in kinetic energy, which is 1,960 joules of energy. C. If the work is done over a distance of so that's from last lesson. If the work is done over a distance of 0.75 meters, what's the average force? Well, I just found the work, and work also equals force times distance. I guess the average force is going to be the work divided by the distance. It's going to be 1,960. I'm going to use my answer button. Divided by 0.75. It's going to be this number divided by 0.75, and I get 2,607.4. I'll go 2,610. And it's a force newtons. A cannon is shot from the Earth's surface to a height of that. What's the potential energy? 1 mark. Well, PE equals mgh. So it's going to be 50 times 9.8 times 4 times 10 to the 2, which is 400. 50 times 9.8 times 400. This will work out evenly. 196,000? Yes, no, yes? Units, joules. What's the change in potential? What's change in anything? So the change in potential energy is going to be mgh final minus mgh initial. I already know mgh initial. Mgh final is going to be 50 times 9.8 times 200. 50 times 9.8 times 200 minus answer button. I'm going to get a negative answer. Well, yeah, because I lost potential energy. I will be fussy. I do need to see the negative. You'll get a delta PE, a change in potential energy of negative 98,000 joules. Where'd that energy go? Yeah. Oh, it's the shell is speeding up on the way down, which again, well, duh, but there's the why that's the case. I always kind of like to know how come some of the obvious stuff happens. Next page over, apparently. Find the kinetic energy of the bike and rider. KE equals a half mv squared. It's going to be 0.5 times 85 times 8.5 squared. 0.5 times 85 times 8.5 squared. And I get 3,070. 3,071. I'll go to 3 sig figs. 3070 joules. 1 mark. The rider coasts up a hill, assuming there is no friction. At what height will the bike come to a stop? I could do this with conservation of energy, but I think what we're saying is all of the kinetic energy is going to turn into potential energy. Like when you're bouncing a ball at the very, very top, no kinetic, all potential. How do I know that? Because it says it's going to come to a stop. So it's going to be 3,070. I'm going to use my answer button, equals mgh. Adam, how would I get the h by itself? Yep. H is going to be 3,070. I'll use my answer button, divided by mg. What was the mass, Mr. Dueck? 85. So it's going to be this number divided by 85 times 9.8. And I get that we're going to reach a height of 3.69 meters. 3.7 I would take. Suppose an object is traveling at 10 meters per second. What happens to its kinetic energy if we double its velocity? It multiplies by 4. Yeah. Why? That's squared. Suppose a toy car is at the top of the ramp, 2.3 meters tall. If we ignore air resistance and friction, how much kinetic energy will it have at the bottom of the ramp? Well, I think this is a job for conservation of energy, but I think I can just say all of the potential at the top is going to turn into all of the kinetic at the bottom. I think I'm going to get mgh initial equals kinetic energy final. I think the kinetic energy final is going to be m 3.5, g 9.8, h 2.3. 3.5 times 9.8 times 2.3. Good stretch. And I get 78.9 joules. So now I can figure out the speed, since kinetic energy equals a half mv squared. V is going to be 2 times the kinetic energy divided by the mass square root. It's going to be 2 times 78.9, I'll use my answer button, divided by 3.5 square root. It's going to be 2 times answer button divided by 3.5 square root. And I get 6.71. And that's the speed, so it's meters per second. This one is 3 marks. How would I give out 3 marks? I think I would give you, excuse me, 1 mark for A. For part B, I would give you 1 mark if I saw that, and 1 mark for the answer. If you got A wrong, but you successfully went 2 times your answer from part A, divided by the mass, and then square rooted, I would give you 2 out of 2 for part B, because you did part B correctly. You just started with the wrong data point.